Hello, this is chapter 4, stoichiometry, chemical reactions. Section 4.1 is about balancing chemical equations. Chemical equations are kind of like the sentences. They have the symbolic representations of the chemicals in a chemical reaction. So on the left-hand side, we have our reactants, and on the right-hand side of the arrow are the products. The larger numbers that are in front of the chemicals are called coefficients, and then the little numbers that are down below the surface are called subscripts. The reactants are kind of like the ingredients, and the products are the substances produced. Now, together, these two sides have to agree, and they demonstrate the law of conservation of mass. Now, we've talked about John Dalton in the chapter before last, but this was part of the atomic theory. Atoms are not created or destroyed in chemical reactions. They're only rearranged. So always, when we're balancing equations, the number of atoms that are on the left-hand side are going to equal the number of the atoms of that element on the right-hand side. So if we have 20 grams or a total of 20 grams of hydrochloric acid and sodium on the left-hand side, it's going to produce 20 grams of sodium chloride and hydrogen gas on the right-hand side. Nothing's going to disappear. Every atom is going to stay on the other side. And the little arrow, I forgot to say that, the little arrow in the middle reads, when you read it out loud, you say yields or forms or produces the products. So these reactants yield these products. So what do I mean when I say an unbalanced equation or a balanced equation? Now, on the left-hand side of the screen, we see hydrogen gas is reacting with oxygen gas to produce water. So there are two hydrogen atoms stuck together. There's two oxygen atoms bonded together, and then we have a oxygen and two hydrogen atoms bonded together. So there's two H's, there's two O's, but then on the right-hand side, on the products, we have two H's and one O. So because there are not the same number of everything that's on the reactant side as on the product side, this equation is unbalanced. Now, to see a balanced equation, we have to adjust the coefficients. We cannot adjust the subscripts, just the coefficients. But we look and see, we know that there was only one oxygen and one of them disappeared. So we need to have two over here. And then when we counted that we had, if you have two of everything over here, then it needed to have one more hydrogen gas over here. So I recommend that you tally the element, make a little list of each of the elements involved in each equation and count them out before and count them out after and make sure that you can account for each one on both sides. So alternatively, to demonstrate the law of conservation of mass, none of the grams disappear either. So if you were to add the masses of the hydrogen gas plus the oxygen gas, it should yield the same on the product side. So here it does not. 18.016 grams does not equal this total. But over here, 4.034 and 32,000 grams hydrogen gas and 32 grams of oxygen gas does yield 36 and 32,000 grams of water. So this one is balanced. So some tips for balancing equations. Number one, realize that only the coefficients like 2 iron atoms can be adjusted, not the subscripts like H2O. So this 2 can, this 2 cannot. Step number 2, I recommend tallying the numbers of the elements on the that are present on the reactant side and present on the product side down below each one of your equations. It's just a very easy way to keep track of things. It helps a lot. Then after you look at the numbers, I would recommend, it seems to me that it's easier if you start with whatever molecule has an odd number of atoms compared to the other side. So if you have 3 oxygens on the right-hand side or 1 oxygen or something on the right-hand side, I like to start with doubling that and trying to balance it with the left-hand side. Tip number 4 is any equation that you have that has a polyatomic ion like PO4 or SO2 or OH, or some of them are kind of larger, but keep them together if at all possible. Just keep it together as a clump and watch how it moves back and forth, or how they balance from the left side to the right side, rather than trying to balance the P's and the O's or don't break them apart into the different elements. It's easier to balance the equation if you keep them together. And then number 5, don't forget to retally your numbers at the end. Go back through and make sure that you've accounted for each one on both sides and that they truly do match. So for the rest of this lesson, I've got 2 short videos on Edpuzzle to watch that are interactive and ask you questions as it goes along to make sure that you're understanding what to do. Neither one of them are very long. Here is the first link. I made a tiny URL to make it shorter. So it's https /tinyurl.com/septkimjohns1. And then the other one is the same URL, but it's septkimjohns2. So after you finish watching these, if you look through section 1 in your book, I'm going to post the answers to the section review 4.1 so you can do some on your own and check yourself and make sure that that you can understand how to do it, because it does take a lot of practice. Don't get frustrated with yourself and just take a break and do something else for a little while if it's not coming easy to you, but just keep going back to it. And it's if you have any problems, and if you can't, let me know if you can't reach either one of these links. So I'll talk to you soon. Bye.